Hi, good morning. So today I'm going to talk about the PowerShell machine learning technique that I had brought up a couple of months ago for the Greater Wall. And I'm going to explain to you why it was a failed endeavor, at least at this point in time, barring some significant breakthrough. And I'll kind of walk you through the steps in my thought process in tackling this. I'll try to keep this video as short as I can, but essentially, the idea was to try to find files that were of a different file type than what they were claiming to be, right? So if there's a file that's something.jpg, is it really a JPEG or is it some other file that's just masquerading as a JPEG, right? We're all familiar with magic bytes. It's a signature at the beginning of a file that indicates the file type, but not all, or actually most file types don't have magic bytes. So the concept of applying machine learning to this problem was to try to figure out how to do that same thing just in the absence of magic bytes. So the requirements that I set out for this were that it had to be lightweight, completely self-contained, and 100% written in PowerShell. So it would be a lightweight machine learning algorithm that you can deploy to an endpoint. It trains itself on the endpoint with the data that's available on that system and tries to determine if a file is legitimate or not. So here's kind of how the script works. It keeps a database of all of the Windows file extensions from a fresh install of Windows. And along with each file extension, it has samples, roughly 5 samples of each file extension that contain the first 100 bytes of those files. Okay, so you'd have a file in question, suspicious.dat, right? Is this really a .dat file or is this something else? What it does is it takes the first 100 bytes from that suspicious file and then it finds in the database the real .dat files and pulls those 100 bytes as well. And it packs it into a data structure that we're going to pass to a DBScan algorithm. And we're going to apply machine learning to it. So this is what I wanted to happen. We have our data structure here on the left built out with the bytes from the real files and the bytes from the suspicious file. We're going to pass it to our DBScan clustering function. And I expected the suspicious one to float directly to the top. It's an outlier. The bytes are too dissimilar from the others, therefore it is obviously not real, and you can identify that. But what actually happened was this. We have that same data structure. We apply DBScan clustering to it, and it ends up clustering sometimes with a legitimate file. Right? Like what I can't explain why that's happening, but a lot of the times a known masquerading file, right? Suspicious.dat is not a real dat file. It's something else. I know that. It still clusters with a real .dat file or any other file type. I'm just using .dat for this example, but this happens a lot. So what I attempted to do to mitigate that, was it became obvious to me that, one of the known good binaries, one of those .dat files from the clean install of Windows is just too dissimilar to the rest, right? And that's why it's clustering, almost like they're both outliers. It doesn't necessarily make it bad. So what I'll do is I will literally duplicate the array of known good files. So you have an exact one-for-one copy of the known goods, right? Because how can it be an outlier if it has an exact one-for-one match? But what ended up happening, again, is the same exact thing. It's still clustered with the random known good binary. So that was debunked as crap, and it did not fix the problem. Attempted fix number 2. So my thought process was that maybe the bytes are just too different, too random. I'm not really sure what the issue is at this point, but potentially applying a convolutional algorithm can mitigate this problem. So the way I think about this is zooming out, right? Zooming out of a picture so that way things kind of look more similar than they really are. All right, I made this nice little visual for you, identify the blue ball. If you're looking at the Earth, when you're zoomed in close enough, there's obviously too much green. That's not a blue ball, right? But if you zoom out by applying your convolutional algorithm and then look at it, it's generally a blue ball, right? You've removed a lot of the tiny details from it. And I thought that maybe this would remedy the clustering issue, but it didn't. So that was debunked as crap. So attempted fix number 3 was programmatic hyperparameter tuning of the DBScan algorithm for the byte count of, my passing in the first 50 bytes, first 100 bytes, first 10 bytes. How many bytes from that file am I going to pass to DBScan, right? What is the epsilon size that I'm going to set for the DBScan parameter, and what is the iteration count that I'm going to set? So I like to think of this like tuning a radio knob, like I have here in the picture. There's so many different combinations of those 3 parameters, and sometimes you can get it pretty close. If you know for a specific file type that this exact tuning works, you can achieve decent results, right? Not too many false positives, not too many false negatives. It generally works. Still not happy with that. I would really prefer that I had no errors at all, no false positives, no false negatives. But you can kind of make it work on a per file type basis if you know what you're doing. But what I tried to do is programmatically do that and on the fly adjust those parameters to what they needed to be until the results started looking good. And the outcome of that, though, was too computationally expensive. It just took way too long to run per file. It was completely unacceptable. And at the end of the day, it just kind of works, right? So it's a huge price to pay for still pretty spotty results. I was not happy with the error rate. So that was debunked as crap. My final thoughts on it. I think that the file bytes of some file types are just too random. Text files, DAT files, things of those natures. They don't follow enough of a pattern to be effective or to effectively apply machine learning to them to determine outliers. The convolution does not alleviate this, and it only works for some file types. Like I said, it works great for DLLs. It works great for EXEs, for PDFs, the picture file formats. It works great for those. But that was never the intent. I've been able to figure out outliers from those files for a long time without using machine learning. Okay, so it was the other ones I was concerned with. And for those, it doesn't work reliably. Hyperparameter tuning on the fly takes too long, and it doesn't guarantee a result. And even if it did, I'm not sure how much I would trust the result. If you've hyperparameter tuned to the point where you're just, making it the way you want to see it, that might not be the desired outcome. And then, like I said at the beginning, barring a significant breakthrough, I'm pulling the plug on this. I'm not going to continue working on it. However, if anyone watching this video finds this interesting and thinks that maybe I was onto something and shouldn't pull the plug, feel free to go ahead and take a look at the code yourself. Reach out to me if you want to. There's a link to my GitHub. I look forward to your feedback. Thank you.